Okay, so welcome back, my dear friends. In continuation to my previous video, in which I described components of an aircraft and some of the important aspects of an aircraft for the basic knowledge of all those students and even other people also, those who are interested to know something about an airborne vehicle or the vehicles which are flying in air. I discussed some of the scientific laws and principles which are being applied to make the aircraft airborne. And I requested all the students to pay more attention, concentration towards their studies so that the real application of those studies they can understand it in a very good manner. Okay, so today, in continuation to that, I have brought the same concept about an aircraft, but today I am going to discuss about the engines which are mainly responsible to make the aircraft move forward. Okay, so in previous video, I told that how wing surfaces which are there on aircraft, it is used to produce the lift force which makes the aircraft to move upwards in air without any physical support of it. Okay, so that particular part only I have talked about in my previous video, and now in my this video I am going to talk about an aero engine which is mainly responsible to create thrust force and which will make the aircraft to move forward. So let us see. In my slide, I have already told that I have already shown the engines which are especially used in aircrafts. So in previous days, you can say, or in premier aircraft which were there in very olden days when the aircraft technology was getting developed day by day. So at that time, piston engine was only used. Piston engines were only, you can say the application of piston engines only were there in those aircrafts. So at that time, jet engines were not used. So even small aircrafts nowadays also it is having piston engine only. Okay, but the aircraft which I have shown in other videos, in previous video and in you can say the video now the picture which I am showing here. So this is actually a jet engine, and at the last I have shown rocket engine actually. So coming back, so lift force is only not necessary, means it is one of the major part to make the object to get lifted up in air. Simultaneously it has to move forward. Okay, it has to move forward with speed, and that particular force which is responsible for making the aircraft to move forward is produced by an aero engine, and this is a separate vast area and which is called as propulsion. Okay, so in aeronautical engineering, our students who are doing BTech in their aeronautical engineering or aerospace engineering, okay, so they all are well aware that propulsion is one of the major areas in aeronautical engineering in which they can gain mastery. Okay, apart from uh, gaining mastery over aircraft structures or any other aircraft systems or undercarriage or even on wing surfaces. So propulsion is one of the vast area, and even it is one of the you can say many very interesting topic, interesting subject for me also. Okay, so that aerospace propulsion actually deals with all those devices or engines which are mainly responsible for creating thrust force. So thrust force actually what it is. See, propulsion means it consists of the word propel, and propel means to move forward, to move forward, right? So the engine, uh, piston engine, which is fitted on aircraft, it will produce power, right? So all engines produce power. What actually is an engine? Engine means some conversion of energy is taking place. Okay, so the responsibility of an engine to convert energy from one form to another. Okay, and at the last we are getting mechanical energy. So you can say if fuel is burned in an engine, so chemical energy of fuel is converted to heat energy, and then heat energy is further converted to mechanical energy, and that mechanical energy will be making the shaft to rotate or the crankshaft to rotate, and through crankshaft several machinery is fitted, especially for aircraft. We do have one propeller in front of the engine, so some two-bladed or three-bladed propellers are there nowadays. Multi-bladed, you can say four or six-bladed propellers are being used simultaneously. Okay, so that propeller is the main engine component, you can say, which makes the aircraft to move forward and making the air to flow and making the air high amount of air. The mass of air is very high, so high amount of air to flow over the wing and under the wing, thereby creating a pressure difference and making the aircraft to have a considerable lift force, which is making it to move upwards. Okay, so as I told that Newton's all laws of motion is being utilized in jet propulsion, whether it is in jet propulsion or whether it is piston engine propulsion. Newton's all the laws of motion is applied here. We all are aware, like Newton's first law. So Newton's first law is also called as law of inertia. And what it says that every body continues to be in a state of rest or in motion unless acted upon by some external force. Okay, so till the time any external force is not acting on any body, it will remain in its position or it will remain in motion also. So the same principle is applicable even for the earth, which is moving, revolving around the sun, or the moon, which is having a rotationary motion. Okay, so revolution around the earth. So this particular law is responsible for that. Okay, second law states that uh, the product of mass and acceleration. So the second law actually gives us the definition of momentum, right? Okay, so principle of conservation of momentum is being applied here. So what actually it is, the product of mass and acceleration is the force is the force produced. So whenever any mass is given some acceleration simultaneously, there will be a force generated, and that force generated is called, you can say, force only. It is not called the force, it is only called, so force is equal to mass into acceleration. Okay, but so rate of change of velocity is only called as acceleration. Huh? Okay, so that force can also be explained or can be defined as rate of change of momentum. As we all are aware, the product of mass and velocity is called momentum. So rate of change of momentum is the force generated, and that is Newton's second law. And very interesting, very important is Newton's third law, on which actually the thrust force is created, and that is, so we all know swimming, we all are aware that how we pull the water backside and our body moves forward. Okay, so the same principle is there, that is Newton's third law of motion, and that is called that we can define it as for every action and reaction, there is an equal and opposite reaction. So this force mainly is responsible, you can say, this law to create a thrust force. So what actually happens in an engine? Okay, especially in an aircraft engine. So piston engine we are already aware. So we provide a fixed mass of fuel and air mixture into the cylinder. Then that fuel and air mixture, it is getting burned. Then heat energy is produced, and that reciprocating motion of piston is converted to rotary motion, and then rotary motion is uh, provided to the crankshaft. So the crankshaft is responsible for conversion of reciprocating motion to rotary motion, and the rotary motion is being transferred to the propeller, which is fitted in front of the engine itself, and direct drive to the crankshaft. Okay, in jet engine we do have some reduction gear mechanism that I will say later on, but in piston engine direct drive almost all. It is given to the propeller, and the propeller will start rotating. Propeller will be having blades. That blades are designed just like wing surface. It will also be having leading edge, means front edge, and trailing edge it will be having. Okay, so similar to the same wing surface, it is also designed, and it will make the uh, air, a large mass of air. It will capture a large mass of air from front of it, and then it will push it backward with high velocity, and which further will be moving. You can say at the top surface of the wing surface and bottom surface of the wing surface, thereby creating a pressure difference, and due to which lift force is generated. Okay, right. So the same way, you can say this is the operation of piston engines, so which are used in small aircraft. So compulsory, we must have one propeller, and the same concept of using a propeller is utilized in helicopter also. Okay, so in helicopter, we can see that main rotor blade is there, which is at the top of the helicopter, which keeps on rotating in clockwise direction or counterclockwise direction. Similarly, to counter effect this rotating motion of the main rotor, there will be a tail rotor also. And nowadays, at the same position, just below the main rotor, we do have another rotor. So both of the rotors will be moving, or you can say revolving in opposite directions, thereby counter there will be a counteract force will be created, and the body will not have a rotary motion actually. Otherwise the body also will start rotating along with the rotor blade. Okay, that is the main reason. There is another rotor is also required. Okay, right. So let us come back. Now piston engine we have already described, and it is producing less power, so it is used only in small aircrafts or training aircrafts. You can say, uh, and it is not flying at a higher altitude, which is flying at very less altitude. Okay. Now next come to turbojet engine. So turbojet engine is a very important engine, and which is especially utilized in fighter aircraft, and which is the basic engine actually. Okay, the engine which is shown in this particular picture, actually it is turbofan engine. Okay, so I am not going to, I will be describing turbofan engine also next. So turbojet engine. So turbojet engine will consist of an air intake through which the air will enter in the engine. Okay, and after that there will be a compressor. So a compressor will be having series of blades, uh, which is further grouped as rotor blade or stator blade. So the air which is entering through air intake, it will be passing through compressor. So as name says, the compressor will compress it and will increase the pressure. Okay, so that pressurized air will be taken to the combustion chamber. So in second picture already combustion chamber is shown, one type of combustion chamber. So this particular combustion chamber is called can type combustion chamber actually. Separate can is there for each combustion chamber. We do have annular combustion chamber, and we do have can annular combustion chamber. So we do have different combustion chamber, and their own merits and demerits are there. Advantages, disadvantages are there. So the pressurized air is taken to the combustion chamber, where the fuel at high pressure it will be injected to the pressurized air, and both will get mixed together, and thereby further ignition will be taking place, and combustion will take place at high pressure. That high pressurized uh, hot gases will be moving rearward, and rearward after the combustion chamber there will be a turbine. So the turbine and compressor both are interconnected to each other. So the turbine will receive the hot gases, and thereby the work will be extracted by the turbine from that hot gas. Okay, and the turbine will start rotating, and as I told you that um, turbine and compressor, both of them are coupled together. Okay, so when the turbine starts rotating, that compressor also will start rotating. Okay, so the turbine will extract energy, whereas to the compressor we are providing energy to compress the air. So both their roles are opposite. Okay, now after turbine, the air will be coming to the nozzle section. Okay, so at the last we will be having a nozzle. Okay, and the very purpose of nozzle is to increase velocity. So as I told you, high pressure energy exhaust gases is going to the turbine. In turbine also some reduction in pressure is taking place, and further reduction in pressure is taking place in the exhaust nozzle, and the same pressure is being converted into high velocity, and which is the main, you can say, Bernoulli's theorem is also applied here. So now that high velocity air will be moving rearward, okay, thereby that will be an action. That will be an action force. And now the reaction force due to that high velocity air which has moved rearward, so it will be creating an equal and opposite reaction force forward. Okay, so on the turbine, we will face, there will be a force generated which will make it to move forward. So as the engine is fitted on aircraft, the aircraft full body starts moving. Whereas the thrust force actually it is produced on engine and on particularly turbine structure. Turbine only is facing that reaction force as per Newton's third law. So as engine in first picture you can see that how engine is fitted on wing surface. So that wing surface, you can say, due to the engine will push the wing surface, the wing is further attached to the central body of the aircraft, so that central body of the aircraft also moves. So this was there, the principle of working of turbojet engine. So the same way it is, all engines are working. Okay. So next one, we will go for turboprop engine. So turboprop means from air intake to nozzle, it will be same. Additionally, one propeller also will be fitted in front of the air intake. So whatever power is being extracted, whatever power is extracted from hot exhaust gases by the turbine, it will be transferred to the propeller. So in this case, what happens? Propeller is the major component which produces thrust force, and through high velocity exhaust gases, less amount of thrust is generated. Okay, so this will be called as turboprop engine. Next, we are moving to turbofan engine. So that third picture, it is already showing that turbofan engine. So in this, what happens? Instead of a propeller, a fan is installed in front of the compressor. So propeller was outside the engine, whereas this fan will be fitted just in front of the compressor, but it will be inside the engine. Okay, so this is the difference between both of them. So turboprop engine actually it is used to carry heavy loads in cargo aircrafts. It can carry heavy loads and all, and a very big undercarriage has to be used for this one. So these are some of the limitations of that, and at very high speed, the efficiency of the propeller goes down, so we will not be able to use it. So below zero point 0.5 Mach, we can say that we are utilizing, or half of the speed of sound. At that speed of sound only, a half of it, this aircraft can work efficiently. Whereas turbofan engine, it will be working more than zero point 0.5 Mach, and up to zero point 0.8 Mach, it will be giving a very good efficiency. Means you can say 80% of the speed of sound, it is giving efficiency. Okay, so now this turbofan engine consists of a fan which is fitted in front of the compressor, okay, and same purpose is there. So the fan engine, what it will be doing, that fan, the fan will suck the cold air, and it will make some amount of the air to bypass the engine. It will not be participating in any type of combustion. Okay, so In this case, what happens? The bypassed air also will be producing thrust. That bypassed air will be passing through the engine uh, engine surface. You can say a separate duct is being provided and it will pass through it, and this particular thrust force is mainly responsible. You can say uh, it will also contribute more, and some amount of air only it will be passing through the core of the engine, which will be participating in combustion process. Okay, so this type of engine produces less noise in comparison to turbojet engine. Turbojet engine, 100% of air is participating in combustion. So turbojet engine, you can say it will produce more noise. So in order to reduce the noise, we can have this turbofan engine, and mostly in all transport aircrafts, we are having turbofan engines, right? Then coming to turbo shaft engine actually it is utilized in helicopter. So the same turbojet engine will be there, and at the end, after turbine, we will be having one free turbine, and that free turbine will be connected with one vertical shaft through some gear mechanism. It will be connected with one vertical shaft, and that vertical shaft will be through gearbox. It will be driving to main rotor blade and tail rotor blade. So, due to the introduction of one more turbine, which is absolutely free, there is no coupling between the main turbine. This free turbine will be completely free, and it will be driven by the hot exhaust gases which are passing through the turbine only. And this free turbine will be responsible to drive main rotor blade and tail rotor blade. Okay, so main rotor blade is the main, you can say, driving force, which will be generating thrust force also, and the engine uh, thrust will be making it to move forward. Okay, then comes to uh, you can say turbofan we have already described, turbo shaft we have described, turbojet we have described. Okay, now coming to uh, ramjet engine. So ramjet engine is the simplest engine. You can say it is not having any type of rotary component. Ramjet and scramjet engine are not having any type of rotary component. Rotary component in the sense that it is compressor, it is turbine. Okay, so there are no rotary components. So very simple engine, ramjet and scramjet. Ramjet engine is having a well-designed air intake. It will be having a combustion chamber and exhaust nozzle. That's all. The only demerit is this type of engine, ramjet and scramjet, it cannot function, it cannot work in low speed. When the aircraft is static on ground, that will not be working. It needs supersonic speed of air to enter in the air intake. That supersonic speed of air which is entering in the air intake will create sufficient compression due to the formation of shock waves, which is mainly responsible for creating high pressure rise in the air intake in the air, and that high pressure air will be taken to the combustion chamber, and directly fuel will be burned and it will be expanded in the combustion nozzle, and thereby we can produce tremendous amount of thrust. So this type of engine uh, makes us to increase the temperature, whereas in normal turbojet engine, turbofan engine, turbo shaft engine, we cannot keep on increasing the temperature in the combustion chamber just because of the material limitations of turbine and other components. Okay, so as it is, these all are missing in ramjet and scramjet, we can very well utilize it to increase the temperature. Okay. So this type of engine is used along with other turbojet engines. So when the fighter aircraft it starts flying at the speed of supersonic speed, you can say more than 1 Mach, then this ramjet and scramjet engine is utilized. Difference between ramjet and scramjet engine is, so in ramjet engine the combustion is taking place at subsonic speed. Subsonic speed means the speed, supersonic speed of air is further reduced in air intake, and then that reduced air speed is taken to the combustion chamber, and there only combustion will be taking place. Again after expansion it will become supersonic speed, whereas in scramjet engine its full form is supersonic combustion ramjet. So the supersonic speed of air which has entered in the air intake is reduced, of course, but not to the extent of subsonic speed, and it will be in supersonic speed only, and the combustion will be taking place at supersonic speed, and then further increase in supersonic speed will be taking place in the nozzle. Okay. And next one, so in all these engines which I have mentioned here, this utilizes the air which is available in atmosphere. So that's why these type of engines are called as air breathing engines. So the oxygen which we need for combustion, so it is utilized by the air which is available in the atmosphere. So the last picture what I have shown, it consists of a rocket engine. So rocket engine actually it works in vacuum also where there is no air. So in this case, in rocket, we need to carry oxygen also in addition to the fuel. Okay, so further rocket propulsion is a very vast area. I am not going to discuss now. In my next video, I will be discussing about rocket propulsion also. So the rocket needs oxygen also in addition to fuel. Okay, whereas in all air breathing engines, we do not need to have oxygen. Oxygen will be sucking from atmosphere itself. The air will be taken from atmosphere itself, and the same is taken for combustion purpose. Whereas in rocket, we need oxygen also. So oxygen is also carried in that, and its construction is also little different. So that I will be explaining in the video for rocket propulsion especially. Okay, so today I am finishing my talk about aero engines to the now at present, and I will have with some more discussion on compressor and then types of compressor and then turbine, types of combustion chamber, all those things also I will bring the video, and that will be mainly for the benefit of the students who are studying aeronautical engineering. Okay, so in more detail they have to go. But for general people, if they want to know about these aero engines and all, so in my today's video, it will be sufficient to give them a complete explanation that how turbojet engine works, how turboprop engine works, okay, and how turbo shaft and turbofan engine is working. So how different engines are utilized for producing thrust here. Okay. Right. So thank you very much. And if you have liked, please share with your friends. Okay. Thank you.